Good morning. Am I audible? Am I audible now? Am I audible to you? Okay. 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 So my screen is visible to you? Is it visible? So my slide is visible to you? Okay. So today we are going to start the next chapter. That means there are some flow measuring devices. Okay, so among the flow measuring devices, one is your sluice gate. Okay, so already you have got these terms sluice gate, isn't it? So what is sluice gate? Let's see. A sluice gate consists of a vertical sliding gate operating within grooves in the sides of the span. An ideal sharp edge sluice gate in a horizontal rectangular channel is shown in the figure. So in this figure, this is your sluice gate. This is the direction of flow. So generally sluice gate is operating as a flow regulating device. Okay. So sluice gate is a horizontal rectangular channel. The sharp edge we did in the downstream. This sharp edge, see, this is a sharp edge. It is pointing downward. Okay. This kind of gate is used for idealized studies as in laboratories. Since the sharp upstream edge provides a well-defined separation line for the flow. As the water issues out of the gate, opening the free surface converges rapidly till the first stream. Till the first stream attains a minimum depth of flow, lines parallel to the bed. Okay, this minimum area, this minimum area section called as vena contracta occurs at a distance about a from the plane of the gate, where a is the height of the gate opening. If the tailwater is not sufficiently high to submerge the vena contracta, the flow being independent in the tailwater elevation as designated as free flow. The flow is subcritical upstream of the gate. So here the flow is subcritical and is supercritical immediately below the downstream. So near the downstream, the flow of water is supercritical in nature. Referring to the vena contracta as shown in section 2, the ratio of the depth y2 to the gate opening A is called the coefficient of contraction Cc. So y2 equal to C suffix C into A. Assuming that there is no entry loss between section 1 and section 2. This is your section, this is section 1 and this is section 2. And so from the energy equation we get this formula. We get this equation using the energy equation. H1 equal to V1 square divided by 2Z equal to Y2 plus V2 square divided by 2Z. Since the discharge per unit width Q is given by the continuity equation, so from the continuity equation we get H1 V1 equal to Y2 V2. So after simplifying, we will get Q equal to discharge per unit area equal to CT A root over 2Z H1. Sluice gets flow. Gates in a variety of shapes and with different operational characteristics are used for the purpose of flow control. For the design, information on the head discharge relationship, pressure distribution and vibration characteristic is required. In this section, the head discharge characteristics of a vertical sluice gate is dealt with in detail. So basically, this is the function of sluice gate. Okay, so let's move to the next slide. Sluice gate, then flow measuring devices, broadcasted Weir. So let me share another screen. Is this visible? Open channel flow measuring device. Open channel flow measuring device. Okay, it should be device. So broadcasted with a finite crest width in the direction of flow are called broad crested weirs. They are also termed as weirs with finite crest width and find extensive application to control structures and flow measuring devices. It is practically impossible to generalize their behavior because a wide variety of crest and cross-sectional shapes of the weir are used in practice. In this section, the salient characteristic only a simple horizontal broad-crested weir are presented. Okay. This is the sketch of a broad-crested weir. Okay. So, in this figure, there is a free flow over a horizontal broad-crested weir in a rectangular channel. So let us consider a rectangular channel. This weir has a sharp upstream corner. which causes, this is the sharp upstream corner in this figure, can you see? So sharp upstream corner which causes the flow of water to separate and then reattach enclosing a separable bubble. Okay, so suppose water is flowing this way. After, if it is reaches this crest, broad crested Weir, it will go like this, isn't it? So after moving certain distance, the flow will again fall along the crest. Okay, let us consider that y1 is the distance, or y1 is the depth of water after that means in the downstream area. This is the upstream area. H1 is the level of water. This is V squared, this is the energy head. YC is the critical depth in this area over the broad crest. Okay, so if the width BW of the Weir is sufficiently long, the curvature of the streamline will be small and the hydrostatic pressure distribution will almost over its width, almost equal to its width. Okay, so the we will act as an inlet with subcritical flow in the upstream direction and supercritical in the downstream direction. Supercritical flow over it. A critical depth control section will occur upstream and probably at a location where the bubble thickness is maximum. Assuming no loss of energy between the section 1,1 and 2,2, we can calculate from the energy equation the total head equal to Yc plus Vc square by 2z equal to 3 by 2. Okay, what happened? Wait. Now is it okay? I didn't lock the meeting. I think it happens automatically. Okay, that's why. Lock meeting. Okay, I have unlocked the meeting. You can join now. Okay, so we are discussing about broad crested. Okay, so from this energy equation we can write Vc equal to root over Cyc. Okay, the ideal discharge per unit width of the broad crested Weir is given by 1.705 h to the power of 3 by 2. To account for the energy losses and the depth at section 2 being not strictly equal to the critical depth, the coefficient of discharge CD is introduced in equation. Okay, so since we have Q equal to 2 by 3 CD root over 2G A LH 3 by 3 by 2. In case of Weir, already we have got this formula. So let's move to the classification of broad crested. Based on the value of H1 BW, the flow over a broad crested Weir with an upstream sharp corner is classified as, if this ratio is less than equal to 0.5, in this range the critical flow control section is at the downstream end This kind of weir is termed as long crested weir. Okay, and finds limited use as a reliable flow measuring devices. Next, if this ratio H1 divided by BW is in between is greater than 0.1 or less than 0.35, the depth of control occurs near the upstream and the V and the discharge coefficient very slowly, and in this range this kind of weir is called true broad crested weir. So these are the figures of different long crested, broad crested, narrow crested and sharp crested weir. Okay, these are the limitations. Basically, on the basis of H1 divided by BW, we can classify different. On the basis of this ratio, we can classify weir as long crested, broad crested, narrow crested, and sharp crested. Okay. So this is the long crested weir. This is the broad crested. This figure C is narrow crested. Figure D is sharp crested weir. Okay. So another one, another devices is there. Let's move to the next device. Parcel flow. So first we have studied sluice gate. Next is broad crested weir, and let's move to the parcel flow. So critical flow measuring devices. Critical depth flumes are flow measuring devices in which a control section is achieved through the creation of critical flow section by a predominant width constriction. In practice, these are like broad crested weirs, but with a major change that these are essentially flow measuring devices and cannot be used for flow regulation purpose. A typical critical depth flume consists of a constricted portion called a throat and a diverging section. Sometimes a hump is also provided to assist in the formation of critical flow in the throat. So this is the throat area, diverging section. Okay. This is the standing wave flume. So what is standing wave flume? The critical depth flume shown in this above figure is known as standing wave flume or throated flume. This flume can be fitted into any shape of parent channel. The throat is prismatic and can be of any convenient shape. Thus, for a rectangular channel, it is convenient to have a rectangular throat, and for a circular sewer, a circular throat is preferable. A hydraulic jump forms on the downstream of the throat and holds back the tailwater. If the throat is submerged by the tailwater, subcritical flow prevails all over the flume. It is used to operate the flume in a free flow mode only, that is with the throat unsubmerged. During the operation of a critical depth is formed somewhere in the throat and charge is its discharge equation is similar to that of broad-crested Weir. This is the discharge equation. This is the discharge equation for this rectangular standing flume. One numerical is given and next is partial flume. So what is partial flume? A partial flume is a type of critical depth flume. Okay, and generally popular in foreign countries. This flume consists of a converging section with a flow level, a throat with a downstream sloping floor and a diverging section. Unlike in a standing wave flume, the head HU is measured at a specified location in the converging section. The discharge in the flume in the free flow mode is given by Q equal to K HA to the power N, where K and N are constant for a given flume. The dimension of various sizes of partial flume are standardized and further details are available. Okay. So this is the partial flume. This is the converging section, crest throat. This is the diverging section. Okay. This is the figure of partial flume. Okay, so these are the different flow measuring devices. Sluice gate, partial flume, standing wave flume, broad crested wave, long crested, narrow crested, sharp crested. If possible, let me share some videos. So let me share the figure of partial, the video of partial flume to you. Okay. I have already unlocked my room. Okay. So let me share my screen. Just wait.
Good grammar and spelling are important.
So is this visible to you? Is this visible?
Yes, ma'am.
ब्रॉड मतलब चौड़ा और शार्प मतलब सकड़ा, ये मतलब है यहाँ पे। ब्रॉड का मतलब काफी चौड़ा।
Sorry. Hindi version है. Let me check another. Now is this visible? Is this visible? Okay. This is a broad crested weir in laboratory.
Voice accomplish la parina yoba. Hajuna voice symmetry voice symmetry tadi hai yoba.
Unmute. Please mute yourself. Mute yourself. Chotu. Roll number 9.
Ay,
Mute yourself.
कि बोले voice symmetry voice symmetry है तो डाउनलोड करनी होगा.
Roll number 9. Kionu. Kionu. Mute yourself. So this is a broadcasted view. Okay. Kiss So, 24 students present today. So let me stop my class. Let me end my class today. So 24 students are present. Okay. So in the next class, I will start the next topic. Okay. Thank you.